Good morning, good afternoon. My name is Tiến Thị Nguyen. I am a researcher at Eurocom and I am responsible for 5G core network development at Eurocom and OpenAirInterface Software Alliance. And join me today is Saga Arora from our team. He's responsible for the deployment of 5G core components and he will be available for the Q&A section. So in this presentation, we would like to give a quick update on the status of 5G core components implementation and the roadmap for the project. So first, let us take a quick look on the new 5G system architecture. For some of you who are not familiar with 5G core network, the new 5G system is relying on service-based architecture, which is designed for cloud-native deployment. And in this architecture, the control plane network function will be acted as an HTTP server, providing the services to the other network functions. For example, SMF provides PDU section services to IMF to establish, modify, or release a PDU section. And this is one of the main differences between 4G and 5G core component. And the second major difference between the 4G and 5G is concerning the structure of the network components. And you can see here is the evolution from the traditional EPC to the control and user plane separation architecture and then to 5G. And the figure on the right shows the mapping between the 4G and 5G components and also give the idea of the functionality of the 5G core components. For example, the functionality of IMF is similar to that of the mobility measurement function from the MME. The functionality of SMF comes from the section management part of MME and the control plane part of SP gateway. Functionality of SSS is divided into a USF and UDM, and also several new entities are introduced to support service-based architecture such as the NIF for service registration and discovery, and SSF for network slicing. Now for our 5G core network project, our objective is to develop a fully 3GPP compatible 5G core network stack at an open source software for the OAI community. In the scope of this project, we focus only on standalone mode. But of course, we also have a 5G core network in non-standalone in another project. 5G core components are under OAI public license version 1.1 and open for anyone who signs the license agreement to contribute. As one of the main projects under OSA umbrella, the main sponsor are Qualcomm, Facebook, Connectivity, and Interdigital. And the main contribution until now come from Eurocom and BPT among the others. For the current implementation status of OAI core network, we had a solid and functional 5G core with basic components such as IMF, SMF, UPF, and NIF. Our implementation supports a basic procedure for connection and registration, including UE registration and deregistration and service requests. And for section management procedures, including PDU section establishment, section modification, and section release. For example, with our core, UE can attach to the network and establish multiple PDU section. Also, with the NIF, we support some original features such as NF registration and discovery. So with the NIF, we can deploy multiple SMF and multiple UPF, and then IMF can discover and select an appropriate SMF based on several parameters, such as network slide information and data network name, just name a few. This feature is very useful for supporting network slicing scenario. Regarding the user plane, for now we use two different flavors for UPF. The first one is SP Gateway U from 4G core network, and we add several additional features to support 5G, such as a new GTP extension header to convey the QFI information. And the second one is relying on VPP traveling with DPDK support to achieve a better performance. And for the moment, we can get up to 600 megabit per second throughput in both uplink and downlink in Docker container deployment, and can achieve up to 2.5 gigabit per second in a bare metal setup. And to guarantee the quality of the implementation, all the implemented procedures have been validated with a professional tester from developing solution in our CI and CD framework. And for the moment, we focus on functional stability and reliability tests. And the strategy is to both test each component individually and test all the components together in an integration test. And most importantly, we also validated our 5G core with the OAI G-Node B with both the OAI UE and COAS UE. So now OAI can provide an end-to-end 5G standalone solution for both RAN and core segments. And we also validated the OAI 5G core with several commercial G-Node B with COAS UE and with some open source RAN simulator as well. We also provide different possibilities to deploy our core network, ranging from the traditional approach to a cloud-native one. For example, to facilitate the deployment of 5G core in our community, we provide a cloud-friendly deployment solution based on Docker Compose. And at the same time, we also deployed our 5G core in Eurocom OpenShift cluster with Helmchart. For the roadmap, we are working on several items at the same time, and some of them will be released in the next few weeks. The first task is to add new functionality such as end-to handover, HTTP version 2, and FQDN support. Originally, we are working to bring new entities such as UDM, USF, and UDR into our ecosystem. At the same time, we are working closely with Mosaic 5G, which is another project under OSI umbrella, to provide standard APIs to external application to collect the information from core network functions. The idea is to provide the possibility to monitor the user statistics information and configure 5G core network on the fly. And this API can also be used by NWDAF entity. For the next step, we plan to add some more features into our existing components. For example, event exposure services for IMAP and UDM for the third quarter of 2021, section and service continuity, redundant transmission for support ultra-reliable low latency communication for the first quarter of 2022. And for a production environment, we will integrate and test our core with a Calum standalone UPF in OpenShift cluster at Eurocom. We also plan to bring some new more network function into our 5G core, such as NSSF, NEF, UDSF, and WDAF, and go further with microservices architecture for the main components. So in brief, we will continue to bring new features and new components to have a full standalone 5G core implementation with a rich feature set. At the same time, to make sure that to have a solid and stable 5G core implementation, We step by step add more and more scenarios to test with the professional tester. We also plan to work on benchmarking to measure some operational and network KPIs such as throughput, end-to-end delay, deployment time, and service availability. And more importantly, we continue to intensively test our core network with OAI G-Node B, with a different commercial G-Node B and open source run simulator with different cost UE and also with OAI UE. And this is a timeline for the project that summarize what I have just presented. And you can check this from the 5G Core Network project website. And finally, here you can find some useful links. For example, the link to the project website, a link to the code repositories, the videos for the tutorial, and the mailing list as well. So that we conclude the presentation, and we will be happy to answer the question.